Okay, so I'm not going to do the intro again, but this talk is about Compose Previews and how do you go beyond the basics. So before I start the talk, how many here are mobile developers? Awesome, perfect audience. And how many have used Compose in their apps, be it work, hobby? Perfect. And how many of you think you use Compose Previews to the full extent? Okay, but do you use Compose Previews? Okay, perfect audience for the talk. Okay, so I'm not going to give an intro on Compose or Previews. I'll just start from a very basic preview and then keep on building on different use cases and show how you can achieve different things with less code. Okay, so this is the structure of a composable. You have a method which is annotated with the @composable annotation, and you have a composable inside it. I have named this method as borrowed item row preview. You will eventually see the UI behind this, but this is how you would start creating a preview. And then you just add the preview annotation. So for a preview to exist, you need to have an @preview annotation as well as an @composable annotation. Now that renders to this sort of a preview. It's a fairly simple UI. The idea behind the app is you keep track of items your friends have borrowed but might have forgotten to return to you, which is a very common use case for all of us. In this case, I'm just using my friend's name, Steve. Xbox is misspelled here, my bad. So it's assuming that my friend Steve has borrowed an Xbox Series X from me on so-and-so date. This UI also has multiple states. So this is an expanded state. There's a collapsible state as well, and we will see how we can preview that in different ways. So this is a fair structure of a preview. And I'm sure most of us are using this preview in most cases. And this is the common thing I see in code bases as well. Before we go into different use cases, a quick recap of the different arguments we have available for the preview annotation. First is a name. By default, the name is the name of the preview method that you created, but you can also give it a custom name to make it easily understandable, because when you start using a camel casing as you do with method names, it gets difficult if you have like a borrowed item row preview dark theme. That's a very big method name. You might as well name it preview1 and give it a self-explanatory name. Second, you have a group. Group is mostly to club together different sorts of previews and avoid decluttering. You will see an example of it later. Then you have the UI mode. UI mode again helps you with things like dark theme, light theme, etc. Again, you will see an example of this. Then you have the locale. Locale is not just language technically, it's language and region. So there can be languages that are slightly different based on the region. One good example can be there is French and then there is Canadian French. They have different locales because some words differ. Similarly, Spanish can be different in Mexico versus the US or maybe Spain. Like you have different sorts of region-specific items in those. Then you have show system UI. You can use this to show your device in a preview. If you don't use it, it's just going to occupy as much space as your composable would. And if you use show system UI, it's going to take up the full screen. As in your composable will still render how you would normally, but you get to see how it fits in a device. You have show background. It's mostly just to display a background color. You can specify a background color as well, but you might or might not need it depending upon how your composable is structured. If it's transparent, you might need a background color, things like that. You have device. This is to specify the sort of device you want in the preview if you are showing the system UI. So it could be a device, maybe a Nexus 5 or a Nexus 4, because they have different screen sizes. Maybe you want to preview it in a tablet, so maybe a Nexus 10. So you can define different devices. And these are technically just predefined width and height. Just a pair of width and height. So if you wanted a custom, maybe you're developing composables for a custom card display, which has a square shape. So you can give it maybe 400 dp by 400 dp. And you have API levels. API levels usually don't matter much in previews unless you are using some sort of APIs that are specific to those API levels. Here you just pass in the integers of the SDK version, so like 31, 32, 33, etc. Okay, so we saw an example of a preview. What if you want to use dark theme and light theme? Again, I don't see a lot of code bases do this extensively. And this is very important if you're creating a design system, because you want to see how your certain UI would look on both on light and dark theme, because it's the design system components that eventually create a UI. Later on, we will see how you can automate this part as well. So I have created a new preview. Here I'm specifying the UI mode as UI mode night yes. Night yes refers to a night theme or a dark theme. Night no would be a day theme. And another thing I've added here is a borrow theme. You cannot really get a dark theme without having the colors for the dark theme defined first. So your theme would give you the light and dark colors, and that's why you have to wrap the composable in a theme. And this is the dark theme version of the composable. You will see the light version soon enough. Next, coming to multi-preview annotations. Let's say you have written a preview. The only difference is you want to see a light theme and a dark theme. You might create two different methods for it. First one with the night mode on, the night mode yes, and the other one with the night mode no. You could create two different methods, but that's again cumbersome, because if you're writing code at some point, you're just duplicating. So you can add two of these annotations. But it can be quite annoying to do that every single time you do. Because again, if you take the example of a design system, you might have like 40, 50, 60 components. Then you will have screens. It's annoying to repeat it, and it's error prone as well. Because while copy pasting or just manually writing it, you might just forget to do it. So there has to be a better way of doing this. That's why you can create your custom annotation classes. So in this case, I'm creating something called light dark theme preview and adding both the annotations. I'm just using an example with two preview annotations here, but you can club multiple. And if you were to use this, it would just look like this. I've just replaced my add preview with add light dark theme preview. This way, everyone needs to remember to use just that one annotation, and you get light and dark theme out of the box. Yeah, just because I use one annotation, I get two previews. Both technically have the same name. So the compiler will just give it indices. So first one will be 0, second one will be 1, because the method name it cannot really generate on its own. This is one example. What if you want to test your UI on both tablets and phones at the same time? That's a very common use case for us. If you have a larger screen, your UI might be next to each other, like it might be horizontal. If it's phone, it might be vertical. So it's very useful to do that. I'm doing the same thing here. The main things to note is I have to show the system UI. Like I mentioned earlier, that if you're using a custom device, you need to show it. And I'm using two devices. One is a Nexus 5X and one is a Nexus 10. One device, one tablet. I mean, one phone and one tablet. It doesn't stop here. You can think of many more use cases. Since I was talking about locales, if your app has strings for all of these different locales, it's very important to test for these. I personally have faced an issue where a customer complained that they were using the US Spanish locale, and certain words were slightly longer compared to the English counterparts, because of which the UI actually got cut. I had personally tested for English and French, but had forgotten to test for Spanish. This could have been prevented if I was using something like this. And you might be wondering where I'm getting all these locale codes from. There's a particular format to it. In this case, the first one is English, second one is Canadian French, and the third is US Spanish. If you want to look at the full format and what are the valid locales you can provide, you can go to the Android developer documentation in the link below, and you get an understanding of how to use a fully qualified locale. Because in addition to region and locale, there are other specifiers you have to provide. For example, in Mandarin, if I'm not wrong, there are slight variations even within the same region. So you have extra specifiers for that. What if you want to combine the custom annotations that you have written? So till now, we wrote two preview annotations. That is the light dark theme preview and multi-locale preview. What if I want the combinations of all of this every time? So you can create a new annotation called multi-locale light dark preview. You can give it any name you want. But the idea is, instead of having to write all of those previews yourself, now you have created this one annotation which will give you a combination of all of these. One thing to note is that when you do this, you won't get all the combinations. So light dark theme preview had 2 iterations, one dark, one light. Then you had multi-locale preview, which had 3 locales. So you might think it will give you 6 combinations, but that's not the case. The compiler again tries to limit the number of iterations it does. So it will give you enough iterations for you to get an idea of what you're trying to check, but it won't become an exhaustive list. Because as you can imagine, this, like, you can exploit this as well. You might just stack up like maybe 18, 20, depending on how you're combining. And that's a lot of previews to manage and render. And the studio would try to avoid that. Okay. Now you have dataset driven previews. Before I carry on, has anyone done a dataset driven preview in your apps? Okay. This is something I didn't know existed either. I did use something similar in the view world, wherein in your XML previews, you can give a dataset. Compose added support for that later on as well. So here I have 2 previews. One has the text PlayStation, another has Xbox. This is a very simple example. But let's say you're creating a book catalog app, and you had like a book named Harry Potter and the Half-Blood Prince. That's quite a long name. And a text box that might work for Xbox might not work for the full book name. So you need to account for a lot of different scenarios where your text might be too short, too long, things might be missing, or maybe you get an empty string. Now, here I have 3 text boxes. Now imagine a complex UI where there are like 4 or 5 different things that can happen. Maybe a button is shown, button is hidden. And if you were to create previews for that, you can imagine the number of data sets you would have to create, because you would have to create maybe 6, 7 previews at least to figure out all the combinations. Wouldn't it be easier if you had one preview, but you had the way to provide a data generator, and the preview would give you a new preview for every iteration of the data set? This is a small example, so I have 2 iterations with 2 data sets. Normally, you could write 2 previews with slightly changed data, but since it's small text, it can work. If there were 3, this would get slightly more complex. What you can do is create a preview parameter provider. So you have to implement the preview parameter provider interface, and you have to provide a type of the data set. So in this case, all my composables need an instance of borrow item. And once I override that interface, I get a method named, I get a property named values, which takes a list. And here I'm giving a list of all the data sets I want. So again, this is a simple example with 2. You can imagine combinations again, like if you have 4 or 5, you might have 20, 25 items in the list. And all you have to do is this, one preview method, but instead of passing in a manual argument, you use the borrow items provider class, which is the class you have just defined, with the preview parameter annotation, and you get an instance. The compiler takes care of everything else. With this, you get all your combinations. Now imagine if you're doing this on your code base. You have significantly reduced the amount you do. This way, you can just create a generators beforehand, so you don't have to wait for the time you're writing your previews. You can have the data beforehand, write previews whenever. Remember I told about groups? This is where it comes in. So let's say you have a preview with the multi-locale light dark preview. This will give you approximately 5 previews. Yeah, you can see that there are 5 here. Here, these are small UI elements and there are only 5. Still manageable. But what if I want to see only a subsegment of it? Let's say I only want to work with dark theme for now, because I'm changing dark theme elements. I don't need to see all of them together. You would have to zoom in, select something. When you recompile, the zoom might go away. It's quite difficult. Now imagine if you had 3 tablet previews in there as well. You would have to keep zooming into your screen, especially if you're on a laptop. It's going to be a mess. What if you could declutter this? this is where group names come in. In this example, I have given group names to each of the previews, English, Canadian, French, and US Spanish. Now, whenever I use this, I will get a drop down like this whenever looking at my previews. So I can filter my previews at one go. So if I'm just changing Canadian, French, I can use that filter, change only the text, and not have to look at English or Spanish till the time I want to look at them. You can create similar ones for phone previews versus tablet previews. Maybe you're just working on the tablet UI. It's like endless possibilities. And groups also help you create a catalog sort of a thing later in the talk. I'll show you a library where, again, groups come in very handy. Has anyone been using groups in their projects while using composables? Okay, great. Okay, local inspection. I'm guessing some would have been using local inspection. Okay, people do. Awesome. So, like I was mentioning, my previews can have two states. Or rather, my UI can have two states. One is expanded, one is collapsed. Now, the behavior for this is actually dependent on an interaction. By default, it will be collapsed. Clicking on it will expand it. But previews, by default, don't have an interaction state. You can interact with previews, yes. But again, that needs an interaction, and then you get the state. What if you want to see things differently? This is where local inspection mode comes in. You can check local inspection mode.current and then change the behavior of a composable. When you're running this on a device, local inspection mode.current will return false. So on device, it'll look something else, but your previews will look something different. And this can have a lot of use cases. For example, when you're looking at previews inside Android Studio, previews cannot access the internet. Let's say you're loading images from the internet. Your previews can't show that. Now imagine a slight complication on it. Maybe you're downloading an image, giving it rounded edges, giving it some sort of a blur, and maybe doing different transformations. Maybe it's a movie app where the poster is slightly edited. Till you download the image, you cannot really do any of it. So previews are useless. So you can use something like this to have a local data source wherein you load a local image, show the transformations, but when you're running it on an app, it actually downloads the image from the internet and does the same thing. This comes in very handy for a lot of use cases. Something I used this for recently was I was developing a feature where I had to show the feed from a camera with certain overlays on top. Now, these overlays weren't really visible unless there was a video behind it. In my previews, I couldn't really show a video because I had to connect to the internet, connect to a port, and get everything. I just loaded a dummy video preview. This also comes in handy later on in the talk. I'll show you how this can be used differently by different frameworks. Okay. Showcase. How many of you have heard of Showcase, the Showcase framework? Okay. So the amazing folks at Airbnb, they release a lot of libraries, especially around Compose, UI. They have a great library called Epoxy for recycler views. So if you're ever looking at anything UI, you should always just look at whatever Airbnb does. They kind of are the gold standard. So they created something called Showcase. Now think of this scenario. You have a large enough app with maybe a big enough design system. Let's say maybe 30 atoms or the components, maybe 20 to 30 screens, and someone joins your team. How do they know what are the different components available in your app? I'm sure most of us don't have extensive documentation that lists out all the UI components, all the possible states. How does it look in dark mode? How does it look in light theme? Maybe font scale, left to right. That becomes especially important for certain languages like Arabic. It's left to right, so you'd have to account for all of that. It's very difficult to do that. Right? Some companies do have this sort of a playground app where there is usage of all the components, so you can go out and play with it. But again, that's a very cumbersome thing to maintain, because anytime you add a new component, you would have to write a screen that uses the component, adds explanation. Then you have a discovery issue. Maybe I want to look for a toolbar. How do I find it? You would have to add a search feature. It's very cumbersome. So what Showcase does is it goes through your previews, generates different possibilities for it, and writes previews for this. So it'll take a component, give it a light theme, a dark theme, left to right. Left to right is default. It'll give you right to left. It'll give you 2x the display scale and 2x the font size. So in case someone, like for example, with maybe vision impairment or maybe just elderly folks who tend to increase the font size. A lot of our apps tend to break when people do that. I know ours does as well. So this is a plugin that generates code that creates an activity that gives you all of this. It's very easy to set up. I'm not going to show you the setup. I'm just going to show you how you can use it and its outcome. Setup, it's very easy. They just have a small README, you go through it. A lot of code generation magic. Okay, so I have these two items. One is expanded, one is collapsed. What I do is, I use the Showcase composable. So if you use previews, Showcase will pick it up by default. It will use the method name for a grouping and do a lot of iterations. But sometimes you might want your own grouping, right? Maybe I just want to see individual rows as a separate section in my UI catalog. So I give it this group individual rows. And remember how I told you that local inspection mode can also be altered in different ways to get different sorts of previews? By default, I am getting always expanded because my local inspection mode is checked inside the composable, and I change my UI to expanded by default. In my catalog app, I don't want that. So I'm manipulating that with a composition local provider. So in this scope, local inspection mode will be false. This is the activity that Showcase created for me. I wrote none of this code. It's all generated. There's a default group. That's for the composables whose previews don't really have any extra information. Remember I named one group as individual rows? It showed up here. And it has two components inside it. If I go inside it, I have the expanded and collapsed state. Because I gave it both the iterations, so I have two of them. Now if I go inside one of them, you can see that I got a light mode, dark mode, right to left, font scale twice, and the display scale twice. The other one got cropped out because the device size was that much. But I wrote 2 lines of code for this entire thing. And you can imagine how this scales across your code base. Your entire design systems becomes discoverable. And if you notice on the first screen, there's a search option as well. So you can search for your components, again, out of the box. And you might think this UI looks a bit bland. So there's a way of getting the metadata as well. So whatever parsing happened, you get the metadata. You can create your own UI. So you can do whatever you want with this, as long as the information is provided to you, and the annotation processor takes care of everything. This uses KSP, so it's quite fast. There's a lot of combinations you can do with it. You can stack them up as well. So lots of possibilities. You can refer to the wiki. It's an excellent library. Okay, animation previews. How many of you knew that you can preview animations inside Android Studio without having to run the app? Okay, few folks. Okay. I personally didn't know initially. I would run it. I wouldn't run my entire app. I would just run the composable on an emulator and then use it. But you can run animations as well. So my composable has a simple animation that when you're expanding or collapsing it, it just expands. There is not a certain expansion, but an animated expansion. When you hover on your preview, you get this option with 4 different action items. One of them is animation preview. One of them is running on an emulator or a device. One of them is in interaction mode. So if you wanted to check the expansion and collapse, you could do the interaction mode and you can click on the item. This is helpful for scrolling as well. But right now we're interested in animation previews. I start the animation preview. Let's see if the video plays. Awesome. Yeah, I'll just run it again. Yeah. So this is a very simple animation, so it's fairly easy to do in the editor. but it's not visible as much, but there is a way of changing the entry and exit. So maybe you just want one side of the animation in detail. You can change the speed. So maybe it's an animation that's fast when the user is using it, but you need to fine tune it, like smaller aspects of it. You can look at that. If there are multiple animations, you can run them in parallel. You can freeze some of the animations. Maybe you don't want the full effect. Maybe you don't want an alpha effect, but you want a scale effect. You can mix and match. So you have a lot of possibilities. You can go on the timeline and check how a certain thing would look at one specific point without needing a device. Again, not all sorts of animations are supported. So I think I'll need to, yeah. So these are the supported animations. You have update transition. That's again, if you want to change the placement of the certain composable. You have animated visibility. That's mostly if you're trying to make something disappear and appear. That's the case for my composable as well. The second half of the UI was initially not visible. I'm using animated visibility to give it that slight animation by default. Any method of the form animate as state. So it could be any property that you're animating. So asterisk is just for all the possibilities. Crossfade, you might not already know. Remember infinite transition, it's maybe a transition that you want to run infinitely. Maybe some sort of a rotating icon, something is retrying, things like that. Animated content, it's to animate as smoothly as possible between two composables. Again, this list will always keep changing as and when improvements happen in the tooling. So this is the state of Compose right now. Eventually, it might just support more animations. Okay, screenshot testing. Okay, again, question to all of you. How many of you have screenshot tests in your code base? Okay, some folks. Personally, we started just doing them recently. We were trying to figure out what sort of library we should use because there are multiple options. Took us some time to figure out what works for us. We had some tooling limitations as well internally because we had a mono repo, so we couldn't really get all the dependencies that we needed. I'm going to walk you through some of the options that are available. Again, I'm not going to show the setup. You can get that from the readmes. But the idea is to show the differences and how you can make a call as to what you want. The first option is paparazzi. If you're a mobile developer, you most likely have heard of the company Cash App or Square. Half of the Android world is run by them. So they have paparazzi. Then you have Roborazzi. Roborazzi is paparazzi version, but with RoboElectric. For those of you who are not familiar with RoboElectric, it's a framework that lets you mock a lot of the Android framework itself. It's very easy to write tests without having to run it on a physical device. Because if you've written tests, you know that you cannot use things like context, shared preferences, and a bunch of other things in your unit tests. RoboElectric kind of emulates that and lets you do that. And finally, you have Google's solution. That's the Compose Previews screenshot testing. I'm not going to be talking about Roborazzi here because it's slightly more complex. It's a very powerful tool. But if I start talking about it and the possibilities, it's going to be beyond the scope of the talk. So I'm going to talk about the first and third options. Paparazzi. It works on the JVM. Why is that important? Till now, whenever we had to do screenshot tests, we had to run it on a device because we didn't have a way of rendering the entire UI without having the context of the device. Now, if you've written instrumentation tests, you know that automatically starting an emulator can be flaky. Sometimes it doesn't start. Sometimes you have memory restrictions. Sometimes it just doesn't work. It's flaky. So if you have on JVM, you technically are not launching anything else other than maybe a JVM process. It's significantly faster, like let's say a few milliseconds to a couple of minutes. That's the difference. So being able to run it on the JVM is very important. It's based on something called layout lib. This is a small library that helps you in that emulation of the UI without actually needing an Android context. This part is important because layout lib changes with different releases. So let's say you are changing your Android Gradle plugin. You cannot really do that. You would have to wait for Paparazzi or other such tools to also update. because layout gets different changes with different versions, and you need to wait for the frameworks to update them as well. It's a close-tied dependency with Android Studio. So that's something to keep in mind. It needs JUnit tests. So the way you write paparazzi test is you have a normal unit test, JUnit. There you define what exactly do you want to launch in terms of UI, what interactions you might want to do, and what sort of theme changes and other things you might want to do. It also supports views. So paparazzi that way is different from the other tools because you can launch views, you can launch composables. It's a very similar API. So if you want to screenshot test your views as well, paparazzi is great. And paparazzi emulates production. This is a pretty important aspect. If you remember, we were using local inspection mode. Whenever you create screenshots using paparazzi, it treats local inspection as false. Even though it's happening in a debug mode in a local environment, you would think that it's the debug mode that's active, but that's not the case. Paparazzi wants to emulate what a user would see, and hence they disable that flag. The structure for paparazzi test is similar to any other unit test. The main thing here is the paparazzi rule, where you give it a device config. I'm using a Pixel 5, and I'm giving it a night mode. And rendering mode is shrink. That's mostly just to shrink the screenshot to only the part that the composable would be rendered in and not the full device. Because again, you don't really need the full device. Just remember how you had to do night mode here, because you had to create a device config, copy and change it to night mode, slightly more complex. And a lot of these modifications are done in a similar way, wherein you change the paparazzi config. Then I just write a small unit test method. Using the same paparazzi rule, I'm taking a snapshot of a composable. In this case, I'm using borrow theme, again because I need the dark theme from my theme, and I'm inflating it with a composable. If you want to bypass the fact that paparazzi tries to emulate production, you can again use a composition local provider and override the local inspection mode to be true. That again depends on what you want to achieve in your tests. Okay, so first time when you run paparazzi, you create a baseline. That's a set of screenshots which will be your source of truth against which future screenshots will be compared. Ideally, these should be committed to your GitHub repository, but not directly, but rather use Git LFS. That's large file storage. It's a more efficient way of storing larger files on Git repositories. And let's say you make some changes, right? Like if you notice, I just added a little space between the name and the date, right? Maybe you did that accidentally, maybe it was intentional, whatever be it, right? You did this, and then you ran your tests. Paparazzi will tell you that the test failed. You will get the before and after in extremes, and you'll get a diff of the images. So here you can see that everything else is same, just the dates have moved around. This is a simple enough case, so you might be able to see it visually. But if you had a very complex UI, maybe the font changed, you used bold instead of normal. Those things can be very difficult to find out on the first glance. This helps. And you can also configure things like thresholds. Say you're okay with a diff of like maybe 1 or 2%. Maybe that's like a device resolution issue or whatever be it. You're okay with that much. You can set up a threshold. Beyond that, it will fail. And the good thing about this is all of these have a certain structure, all of these comparison screenshots. So you can have a CI job with that whenever the tests fail, pick up those images, put it in the pull request. So no one has to, like, if you are a reviewer of a pull request, you don't have to go check out that branch, run it, tell them that, hey, you missed something here. All of this is automated. Okay. Lastly, the Compose Preview screenshot. This is something, again, Google has recently released. It's still in very early alpha. I think at the time of this talk, it's in alpha 7. So it's quite far away from being production ready. But then again, it's not much of a production thing because you're using it in your local setup. So you can go ahead and start experimenting with it. There are lots of bugs with this at the moment. They're resolving that with every release. But you can track the bugs. If they are not a deal breaker for you, you can go ahead and use this. There are some small differences from Paparazzi. Good thing is it's still again on JVM. Don't need a device, very fast. It's based on layout lib. Again, same thing as Paparazzi. It's fully automated. The reason I say it's fully automated, you do not really need to write extra tests. No running JUnit tests. Now, if you're someone who hasn't written tests before, learning to write unit tests is still some sort of a friction there. In this case, you just write previews, nothing else. So if you are a developer who does mostly UI, you continue doing that. It needs a special directory though. For this plugin to work, you need to have a screenshot directory inside which you need to give you the previews for which you want the screenshots. That's some slight difference from Paparazzi because there all your tests just stay in the unit test folder. And it emulates debug. So the local inspect mode will be true in this case, same as what you see inside Android Studio. When I was mentioning the structure, you can see that I have like a main, I have a debug, but then I also have a screenshot test in which I have a whole Kotlin package inside which my previews live. Now, again, this is a preference based on how your workflows are. If you prefer having your previews inside the main code base, this might not be the best for you because your previews need to be here. With Paparazzi, you can have your previews inside the code base and just call them inside your Paparazzi scope. So depending upon what you prefer, you can choose different options. And let's say inside my screenshots folder, I created again a light dark theme preview annotation with different providers. What it does is it creates the debug folder for me. Inside that there's a screenshot test, and then I have the reference images. If I go back again, you would notice that the file name is borrow item row previews. Here the directory is called borrow item row previews because it uses the same file name. And inside them, you will see that device dark theme preview, device preview, different options. It just went through all the iterations and created these screenshots for me. Again, this is the baseline creation. I ran the test, similar cases earlier. In this case, my reference image had the gap and my actual image didn't have the gap. This test failed for me. Here, the result is slightly different because there was a size mismatch. So it gives you that indication. If the sizes were same and pixels changed, it would give you an indication differently. Again, both the frameworks give you a report wherein you can do all the comparison by yourself. So if you just want an HTML file that tells you where all you went wrong, it can do that. Okay, what if you cannot decide which option is best for you? It's quite cumbersome if you choose one option, convince your teammates, move to it. Maybe a month or two down the line, you don't like it. You think the other one's better. You want to go to that. Happens all the time with our frameworks, right? We choose a library, it goes out of date. We don't like the API. Tons of reasons. There's this really nice framework called Composable Preview Scanner. What it does, it lets you write the tests in one go, and you can choose what you want to use to run the tests. So you can configure the same tests to be run with Roborazzi, Paparazzi, or Google's tooling. So you're not really rewriting the tests, you're just changing the provider for the tests. This has a bunch of other nice utilities as well, so you can go check it out. It's great for anyone looking to get into UI testing and screenshot testing specifically and not having to worry about changing too many things. Okay. After this talk, if you want to learn more about this, where do you go? I would definitely recommend looking at Roborazzi. Great framework, builds on Paparazzi and RoboElectric, very powerful. Again, all of these different frameworks have some differences here and there. Like with Google's tooling, you can change the API levels, but you cannot do that with Paparazzi. Some of the frameworks will allow interactions, others won't. Roborazzi, as far as I know, has support for complex animations as well, but Google's tooling and Paparazzi don't have. So there are lots of different iterations you might want to do depending upon what's your use case. And the second is a talk. It's an excellent talk. It's by the author of the previous library. It's called Composable Preview Driven Development. You might have heard of TDD, where you write your tests, execute the code. You write your test first and then the code to make sure that your code actually adheres to the test and it works fine. This person takes the same philosophy for composables. Has the preview, tries to match the preview, goes that way. Like they use the preview as a rapid source of feedback, similar to what you would do with tests. It's a full talk. Excellent way of figuring out what you want to do. And he also talks about the library there. Yeah, that's it for the talk. If you have any questions, please go ahead. Yeah.
So I'm not able to understand the comparison to the reference image, right? So where will we have
The reference image, that's the first one that you created. So once you integrate any one of the frameworks, they have these Gradle tasks, usually called record or something like that. Once you run it, it generates all of these images. That's your reference image and that's the baseline. That is what's stored in your repository. When you run the tests, it creates the actual images and then it compares. So the test results, they're actually temporary files inside the build folder. So if you do a Gradle clean, it will go away. But the reference or the baselines is what's stored. They have different paths. Yeah.
So if you have something like a Lottie animation, or let's say a composer, how are you going to do A/B testing?
So as far as I know, Paparazzi and Roborazzi have support for Lottie. What they do is they create a GIF out of it. So instead of an image, it's a GIF. And there is one small difference that you have to do. You have to force Lottie to run on the main thread. Because Lottie does some operation on the background thread to offload. When you're writing these tests, you force Lottie to use the main thread for everything. And that's what it lets it do it in a synchronous manner, and Paparazzi can capture it. So similar to how you saw PNGs, it would create a GIF. Yeah.
So we have frame by frame animation.
Yeah.
So it works with previews.
A frame, yeah. Yeah, it'll work with previews. Yeah. Thank you, everyone. Also, if you want a link to the slides, I'll be uploading them at the QR code below. It's a link to my speaker deck where I'll post a PDF of this.